The resting membrane potential of a cell is the difference in charges on one side of the plasma membrane versus the other. These charges come from ions like sodium and potassium. The difference is measured to be about negative 70 millivolts. We use the word negative to indicate that there are more negatively charged ions in the cytosol than in the extracellular fluid. Since there is a positive and a negative side of the membrane, like the poles of a battery or a magnet, the membrane is said to be polarized. Now these ions can't cross the plasma membrane because of the lipid bilayer. But if membrane proteins called ion channels are open, the ions can travel through them into or out of the cell. The problem for ions is that these channels are typically closed by gates, and only specific stimuli can open these gates. The main stimuli that open ion channels are voltage, mechanical stimuli, or chemicals, which we call ligands. Let's explain this with a couple of examples. In the case of neurons, the concentration of sodium is higher in the extracellular fluid than in the cytosol. The opposite is true for potassium ions. When the right mechanical or ligand stimulates the receptor on a sodium ion channel, the gate opens and positive sodium ions diffuse down their concentration gradient into the cytosol. This changes the membrane potential by making the cytosol less negative. Since the change makes the membrane less polar, it's called depolarization. If this were a potassium ion channel, potassium ions would diffuse out of the cell, making it even more negative. This is called hyperpolarization. Each of these examples is called a local or graded potential because it only affects the immediate segment of the membrane and its amplitude is dependent on the number of ion channels stimulated.